Hi students, today we'll be looking at lesson 2 of chapter 7. So let's do a quick recap. So in yesterday's lesson, we learned that metals, right, are made up of tiny particles, and these tiny particles, right, are always moving in a random order, and such motion is called a Brownian motion. So today, we'll be looking at part 2, which is the models of metal. So it's basically, right, some models, right, to explain the different properties of a solid, liquid, and gas, like how are these like particles being arranged in a model. So for the question of the day, we will be investigating these 4 key terms over here, or key points over here. So you can copy on a post-it and paste on page 3, so that when you want to revise, right, you know what are the questions or what are the key focus you need to focus on when you revise this part of the chapter. So for the particles in solid, liquid, and gas, we need to know like how are they arranged, how are they spaced apart, how strong are the forces of attraction between the particles, and how do they move in these 3 different states. So let's do a quick recap. So we know that metals can be classified into 3 states: solid, liquid, and the gaseous state. And each stage, right, has different physical property. So in primary school, you have learned that for solid, liquid, and gas, solid and liquid, no, solid has definite shape, while for liquid and gas, right, they has no definite shape. They take the shape of any containers or any things that they can fill up. For volume, right, it has a definite volume, as same as for liquid also. So what does it mean by definite volume? The word definite just means, right, it has a fixed volume. Fixed volume. So you can like write it down somewhere. If you're unsure on what's the meaning of definite, you can just write fixed. So for gas, right, it has no like fixed volume. That's why it can be compressed. So for density, the density are in this order from the highest to the lowest. So the one with the highest density, right, is the solid, followed by liquid, and lastly the gas. And in terms of compressibility means whether it can compress or not. For solid and liquid, they cannot be compressed, while for gas, right, it can be compressed. So for these properties over here, right, we'll be investigating it in the next lesson, as we'll just be focusing on like the how does the model of metals work, like arrange the forces, the movement, yep, in solid, liquid, and gas for this part of the lesson. So particles of metal, right, they are very, very small, and we cannot be seen with our naked eyes. So that's why we need to have some model, right, in order for us to like show how these particles are arranged in different state. Similar to like the cells model also. So the models, right, are just created for us to understand like and study and learn what are the properties of solid, liquid, and gas. So models are just help us to like learn something. So let's move on to the next part. So the particles in solid, liquid, and gas, right, they are different in these following 4 ways, which is basically the question of the day. So we'll be looking at the arrangement, the distance, and the strength of forces of attractions between the particles, followed by how does these particles, right, move in solid, liquid, and gas. So let's look at the particulate model. So this particulate, right, it just means particles model in simple words. So when we ask you to draw the diagrams of how the particles are being arranged in solid, liquid, and gas, right, you need to draw in this following manner. So for solid, they are very orderly packed and they are quite close to each other. So it's like they are in order. For liquid, they are also close together, but then you realize that all the particles, right, they are all like not arranged in a proper manner. So they are like in a disorder manner. And for gas, they are like far apart from one another, and they are like randomly placed also. So when you draw this type of diagram, right, you must make sure that all the circle, right, must be of equal size. Because if you don't draw in equal size, right, it means that they are all like different types of particles, which is not what we want to represent. So you must make sure that all of the circle over here, right, they must be of like equal size and shape. Yep. So basically we use circle to represent it. Okay, so for the model of metal, just like you see in the previous slides. The particles in the solid state, right, they are arranged in an orderly, or you can say in a regular manner. While for liquid, they are like packed in disorderly, or they can like in a random manner. And for gas, right, it's disorderly and random. So referring to the distance wise over here, distance, you realize that for solid, right, they are extremely close to each other. They are like minimum no space in between each of the particles. While for liquid, right, they seem to be further apart a bit, but they are still close together. But for gas, right, they are very far apart from one another. Okay, so what does this mean? So for solid, right, since they are very close to each other, they can feel like each other attraction forces. So that's why they have very strong forces of attraction. So if you want to put it in a human way, right, for example, if a friend of yours, right, sit quite close to you, right, you'll feel the presence of your friend. So that's what it means, like the forces of attraction. So the further it is, right, that means the force of attraction will like decrease. So let's say your friend like sit like two tables away from you, right? Then you won't be able to feel your friend's presence. Yep. So for liquid, right, they have strong forces of attraction between one another, but it's still less than solid. While for gas, right, they have very weak forces of attraction between one another, as they are very far apart from one another. So these forces of attraction, right, it seems to be like negligible, means right, it cannot be. It's very 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 weak. That is not that it appear to be like not there at all. So for the movement of particles, for solid, they are basically vibrating about its fixed position. So it like just vibrate on the spot. And for the liquid, right, they are basically like sliding across one another, slide across one another. While for gas, right, they move up freely in all directions, very rapidly, like lightning like that. Okay, so I will show you the video, like the animation, right, after this video, so you can take a look at how it really like move in this solid, liquid, and gas. Okay, so let me use an analogy to like enhance or like your learning or reinforce your learning. So imagine in your current classroom seating arrangement now. So in a solid state, right, they are very orderly packed, just like how your table is being arranged right now in a exam order. They are all like individually packed, yeah, in a very orderly manner. So you see all the rows, right, they match each other and all the columns match each other. Okay, so in your particle model, right, you need to ensure that all your particles, right, must be circled, not rectangle as I show over here. This one is just an analogy, just like to help you understand it better, using something that you can relate to. So they are very orderly packed. So when they're orderly packed, right, means right they have low amount of energy. So you can think of it like having a lesson that is very quiet. So it signify that you have very low energy. So you just like want to sit down at your own place, don't want to do anything. So it's like orderly packed, but then low of an energy. Okay, so this rectangle over here represent like one student. So now you imagine all the students are sitting at their own seat and it's like in a low energy mood. So they don't want to like, move anywhere, they don't move about. Okay, so for liquid, right, you can think of it as like now all of you, right, are like sitting quite close to one another, which is not right for this moment of time. So they are sitting quite close and like in a very messy manner. Like for example, your other lesson where you like feel more excited. Like for example, when I ask you to do quiz here, you'll be very excited. So all of you like you'll be like placed randomly when you go to your different groupings. Yep. So it's like slightly more energy as like it's some activity that can attract you better. And for the gas state, right, all of you seems to be like very randomly placed and very far apart from one another. So if for example it's like your recess time like that, when you hear your recess time, right, all of you very energetic. Oh, want to go for recess, want to go and play, but not for now. Or your PE lesson. So all of you are very like energetic and like go all over the places and very far apart from one another as you have the energy to like move further. Okay, so we have answered our question of the day on how are the particles being arranged in a solid, liquid, and gas, followed by how are they spaced between one another, and how strong are the forces of attraction between these particles, and lastly, how do they move? So let's do a checkpoint. So the diagram below, right, shows the particulate model of a solid, liquid, and gas. So can you identify, right, which is a solid diagram, which one is a liquid diagram, and which one is the gas diagram? So you just need to fill in the blanks, the box over here, and this is found on your page 7 of your notes. So for the content in between, right, like for example, page 5 and 6, right, we'll cover in the next lesson as it requires explanation where you need to be familiar with your particular model first before we can like explain, go into this explanation. That's why I will stop and keep the explanation for the next lesson. Okay, so after you think about it, pause the video, think about it, and fill in the answers in your worksheet. Okay, so the first one should be solid. It's because solid, right, they are orderly placed and they are very close to each other. The next one, in the middle, this one is a gas. And this is because, right, gas are very far apart from one another and they are like randomly placed. So far apart and randomly placed. For liquid, the last one, they are quite close to each other as compared to gas and they are randomly placed. So this is how you can identify a solid, gas, and liquid particles model based on how the diagram is represented. Okay, now for the next one, question 2. So for question 2, the diagram below shows a three-dimensional model of metal. Look like this over here. And the arrow over here, right, just means, right, the directions that the particles are moving in. So what can you say about this 3D model over here? So there are a few options for you to consider. So the first statement says that it's a model of a gas. Okay, think about it. Second statement says that it's a model of a solid. Third says that particles move in random directions. And lastly, the last statement says that the particles varies about its fixed position. So if you can look at the statements over here, right, basically just like two things. You need to identify whether this diagram over here, is it a gas or solid? Because the statement 3 and 4, right, basically are like stating how does the solid and gas, how does the particles in solid and gas, right, how do they move in solid and gas? So pause for a moment and answer the questions in your worksheet. And I will need you to answer the questions, this question also, in the same SLSA lesson also, so that I can like see where are you at. Okay, so I believe you have like think about it. Okay, so for the answers, right, it will be 1 and 3. This is because in order for it to become a solid model, right, we know that solid model in the previous question, they are very orderly packed or arranged and they are very close to one another. So in this case, right, these particles over here, they are very far apart from one another. So that's why there is a model of a gas. And statement 3 fits better than statement 4 is because these particles move in random direction. Yep. So the answer is A. So for your homework, I will need you to do this theory book volume A and do these two questions. Question 2 and question 4A. So it's basically found on page 75 and 76 of your workbook. And you need to do the map it out on page 77 also. So these are the three questions that you need to do. And for question 4A, right, it's a true-false question. So if it's a true statement, you just put a tick. If it's a false statement, means means you feel that it's not right, it's wrong. You put a cross, and you need to write down what are the correct statement. Yep. So as I promised you, there will be a pun for watching this entire video. Okay, so this is the question of the day. So before we go to the pun, for the next lesson, as I mentioned previously, we'll be using this particular model of solid, liquid, and gas that we learned today. That means like how are they arranged, how are the distance between the particles, what are the strength of the forces of particles, forces of attraction between these particles in the solid, liquid, gas, and lastly, how do they move in solid, liquid, and gas, to explain the different properties of a solid, liquid, and gas that you have learned in primary school. For example, why can gas compress as compared to a solid and liquid? So this is one example of explanation questions. Let's go. So what was the last word of the flame? You mean the flame? You know the flame, like when you cook a pot of water, right? There's a flame below, like from the gas. Say to the boiling water. So basically, the flame say, "R.I.P. boiling water. Rest in peace. You will be missed." You get it? Hey, I believe some of you understand it, and some of you need a little bit more time to understand this pun over here. Okay, so if you understand, you can share with your friends. If you don't, you can ask your friend also. Okay, so that's it for today's lesson. Thank you.